chaos and chaos and chaos. As usual, everything this is not needed. Second, I will put what I'll do. I will put a link to the stream into your learning system. Do you have access to Ortus system?
Yes.
So this means what you can see our lectures, basic of signal theory. And also you, this means what you have access to my, previous year.
Yes.
Yeah, lecture 2, introduction, it's okay, it's here. I'm going out of this. Mikrofons ieslēgts. Atvainojos, mums sanākusi problēma pārklājas Daugavpils lekcijas. Ieplānojuši otrdienas ārzemju studentiem kopā. Nē, nākamnedēļ latvieši. Ar šī nedēļa sanāca, ka jums pārklājas ar angļu valodu. Cirks un zirgi. Nu, vat, nezinu, kurš to jums plānotais. Man vienu nedēļu otrdienu latviešu, vienu nedēļu angļu. Un saplānojuši jums ar angļu. Nu, vat tāda dzīve. Labi, es pārsvaršu pie studentiem. Nu, ja kas var vērot angļu variantu? Nē, 23. Es visu 23. gadu arī pieliku klāt. Šodien es noredigēju un viss 23. gads ir. Nu jā, es to skaidroju pirmā uzdevumu. Tur man ir 4 uzdevumi ar punktiem. Lai dabūtu eksāmenu, nu, kaut vienu izpildu. Ja tā, lai... Ir, es veidoju paraugus, nonāks līdz tām. Es iziešu cauri, kā tas viss notiek. Bez diskrēta transformācijas pagaidām tas viss ir bezjēdzīgs. Es izskaidrošu, viss būs. Labi, es pārslēgšos pie. Nu kā, pie mums ir vārda brīvība. Labi, jāstrādā. Labi, jā, labi. Jā, es visu kursu pieliku. Un tur ir paraugi citiem stāt. Visu atslēgas. Haus, Haus, Haus. It's ein Haus, Haus, Haus. Here I'm going out. Here I'm going out. Here I will come back. And I need, what I need? I need to do something. Nice chat, but it's not for this lecture, it's for the next. I can switched off. And what I need to do, I need to start with small circle. Sorry, small mistake. Since it's a first time during this course, I can tell what will happen here, what we are all about. Maybe appear here. Oh, my camera. 1 second, 1 second, 1 second.
Just because you didn't beat again first, how can you physically get 20?
See, tiny problem. I don't have this sheet, so I will fill it by hand at the end of. I don't have this device. First, what we are here about? What is the theory of signals? Why are you here? Trying to scramble my presentation because I have presentation but wrong. Yeah. So, theory of signals. This course is intended for power engineering students. As I may think you mostly are not from power engineering course. Mechanics, avionics, and all of that. But this course is, we have two parallel courses of theory of signal. One for communication students and one for power engineering. This one is for power engineering. So not all from this course will be usable for you. But I hope at last some ideas may work. Usually in the same mass idea works very well in mechanics, in thermal engineering, and so on, so on, so on. But for us, for guys who do with power engineering, theory of signals comes after the theory of circuits. But I have a feeling you knew nothing in theory of circuits. Who knows anything in theory of circuits? Anything? Heard about it? Yeah. Yeah, case program. So I will, forgive me, but I will speak a lot of, let's say, in electrical dimension. But if you don't understand it, please raise your hand and ask what is it? Because electrical engineering, power engineering isn't so easy to understand. Name theory of signals. See, when you invent some science, who first invented receives let's say, preference to name it. Because communications are there, because communication guys were first to, let's say, open this theory. It's named theory of signals. If you want, you may name it advanced theory of circuits. Ground. Yeah, that's good. Now, of course, you would like to, 1 second, I'll finish assembling my network. Oh, I need this. I'll finish assembling my network. And I will try to explain what's it all about. I need no. This is goes here. Ground goes here. Second ground goes here. And home. And this will be here. Move it away. Where am I? Yeah, here am I. So, what I promised, to tell what it's theory of signals. What's it's all about. I will repeat myself a bit. So, I will use this designation, signal. Anything what you can observe in time, any physical value. It may be voltage or current or I don't know, pressure or number of students. Anything what you can observe physical in time, it's good as a signal. Definition signal, again, it's any physical value what can be observed in time. Yes. Next idea. Signals are determined and stochastic. If you have a mass definition allowing you to tell what will be value of signal for any time, any point of time, okay, it's fine, you have determined signal. If you only operate with probabilistics, with probability, it's a stochastic signal. Signals are periodic and non-periodic. If you can write that your signal repeats, if your signal repeats itself, time, it can be anything, not important. Important, but if it repeats after period T capital, it's a periodic. Never repeats, non-periodic. Okay, here, repetition period in seconds, milliseconds, seconds, and m capital is an integer. It's an integer number. From minus infinity to plus infinity, m is an integer. Periodic signal. It is sometimes it is very preferable to easy to work with periodic signals because solution often requires only operation within one period. Next, think about signals. They are continuous signals. What's about our time? We have year, yeah? Where can be divided in months. Months in day, day in hour, hour in minutes, minute in second, second in millisecond, and so on, so on, so on. Our time is continuous. We have no, let's say, granular or discrete in our time. But let's assume I have an experiment. Let's say I attach a wall gauge to it, and one sleep student watch it and bring me a report. Okay, he watched. I got a report. Time, voltage, 1 minute, 2 minutes, 3 minutes. I don't know, 5, 7, 3 volts. Nice. Nice? Nice. Time, original signal. I don't know. 5, 7, 3, something like this. This signal is continuous. It has no interruption in it. For any time it's existed. What I got? 1, 2, okay. Here, for example, was point number 2, and here was point number 3. I got a set of measured points. Yeah? Yeah. For simplicity, I can assume an equal time between measurements. Now, good question. What do we see here? What's the signal value at? For example, here, 2.5. Can we tell it? No, not measured. Maybe it was like this, or maybe like this. No one knows, and nobody knows in future, because not measured, undefined, unknown. This table, or red dots on my blackboard, are what kind of signal? Discrete time signal. Why I'm talking about this? It sounds like kind of nonsense. What means discrete time? We live in digital time. We don't have analog signals anymore. We have a digital processing. Digital system, microprocessor system, works in discrete time. Our time is continuous. Machine time is discrete. It has a granular. Unknown, uncalculated, unmeasured. Discrete time signals exist only. They have any sense where they are measured, calculated, processed. Outside these points, they are unknown. Digital time is not continuous. Our analog time is continuous. For digital systems, time is discrete. So if we speak on digital processing, we will speak in discrete time. Sooner or later. What's also important, there is a special group of signal, kind of cosine or sine, let's say omega, where omega angular frequency is double P divided by repetition periods. Special group of periodic signals. Such signals are called, got their name as harmonic signal. Ideal voltage, ideal current, ideal sound, they all are harmonic signals. Harmonic signals, sine or cosine. There is a particular differential equation describing an oscillation. such signals are solution to this equation. You'll see. So ideal current, ideal voltage. Now, what kind of presentation I got? What I'm willing to show? I have a very simple circuit. 0.1 microfarad capacitor, 500 ohm resistance. At the input, it's a voltage for X. At the output, voltage for Y. Sorry, it's a function of time and time. Yellow line of the scope is X. S6, not the blue line. Output SY. Q and Y. Алло, стой, не звони. Занятие. Okay. Very simple circuit. Yellow line. What about scales? I would like, yeah, 2 volts and 2 volts. Oh, here they are. I have nice harmonic signal with a frequency of 10 kilohertz. Frequency, 1 against repetition period. Here, 10 kilohertz. So change 10,000 times per second. Yellow line and nice blue line. It's the last time you wait. I would like to write output as a function of the input. And here, I got problem because you don't know anything about electrotechnics theory. This voltage is nice. .5 volts, nice voltage. This voltage can be written as a sine omega t. Nice. But to perform a calculus, here it is as a function of time, the yellow line. To perform calculus, electrotechnics use an interesting trick. See what's the problem. This circuit, what I have, capacitor, resistance, I can, and here is my voltage source. I can write a second Kirchhoff's law, or Kirchhoff's voltage law. What's a Kirchhoff's voltage law? Sum of all voltage in a closed circuit equals to 0. And Kirchhoff's current law, first Kirchhoff law, sum of all current in any node equals to 0. Here I can write a Kirchhoff's law. So it will be equals to What will be voltage on capacitor? Classical physics. Voltage on capacitor is a sum of all charges flown into capacitor. Yeah? So, what is 1 against capacity from 0 to time. Yeah? Sum of all charges. So, it will be 1 from 0 to time plus E. It's the same current. Nice equation, easy to solve. Yeah? Of course, you can solve this equation. We need this output voltage. It's not so pleasant to operate with it, isn't it? Yeah. So, electrotechnics use one interesting trick. This is what the trick use electrotechnics. Idea is to eliminate differential equation. Go from differential equation to simple algebraic. To do so, one trick is done. It's idea of Oliver Heaviside. In reality, this theory developed by one guy called Charles Proteus Steinmetz. If my memory works fine, it was 1952. So, idea. You can assume you have something like sine, let's say omega time. What you can do? You can incorporate a complex plane. What is a complex number? Who can tell me?
Number that can be represented with the real part and the imaginary part.
Imaginary
like
part.
A plus BI.
We assume what? There is one I or equal to square root from -1. It's imaginary number. If you do so, you will be able to do a trick. On your accounting book, you will have one number. Let's say I mark it with the dot, but it's not a simple number, but a tricky number. Having a real part and imaginary. It's a vector. Number 1, but parts are 2. One number can represent 2 coordinates. So, idea, if we, maybe I have a colors. Take a look, this angle. See this angle? I can write my x as a model multiplied, wait 1 second. I will write real part of my x, a equals to real part of my x, it's amplitude multiplied by cosine of phi. On the and second one being imaginary part of my x being by sine of phi. Compare this and this. Sine and sine. Yeah? So, electron harmonics do one trick. We can assume what this imaginary part or projection of some vector is our voltage. We can assume that all complex plane rotates with the speed of omega. And voltage is a, let's say, shadow. Put a light here. What our voltage is a shadow of this rotating vector. It will be, do I have something? Here is the time axle, time 0. What will be value of shadow projection? Light source from the window. Light comes from the window. What will be? What will be value of voltage if light comes from the window and this is voltage vector? This is voltage vector. This is time axle. The time goes up. What will be value? 0. And in this moment, full voltage magnitude. Again, 0 voltage magnitude with a minus sign. Understand? Idea of real voltage, real current. This is real. What this one is a shadow of rotating vector. Vector rotating with 10,000 revolution per second. Light from window and its shadow produces this thing in time. Why it's done? Appears like some kind of madness, isn't it? Who needs shadows of vectors? Idea of this technique is in very important thing. To get capacitor voltage, I need to integrate, yeah? But mass for this vector will be a power j omega t. Just apply our formula. What will be integral of this? Eh? For any, I assume 0. For anyone, a power j omega and plus r imaginary of x divided by real of x. If you integrate, it will be 1 divided by g with all this and the same exponent, yeah? And division by square root of minus 1 means what? Multiplied by 1 means rotation forward by 90 degrees, division, rotation backward by 90 degrees. More of that. Since all vectors, until the system is synchronous and all vectors rotate together, I can omit frequency. This thing is synchronous generator. Here I need to put excitement current that I will get three-phase voltage out. Of course, if I supply mechanical energy. Here I attach the complex plane. here I have EMF, it's this vector represents A phase voltage and blue current. I rotate, imagine time x going up. Black vector, shadow of the black vector will be 0, 1, 0, minus 1, and so on. And current, here, green. Is there any difference in current placement relative to voltage? I rotate generator or not? 0. I can stop the complex plane and analyze without a frequency. I will need to take care about frequency because capacitor is recharging. But in general, here is a very good idea. I can switch from integral differential equation into algebraic equation by substituting real system in time with system where complex plane rotates in time and operate with the shadow operation of some vectors. Assume what this is a shadow of this vector rotating with the frequency, okay, I can't reach 10 kilohertz. One more idea. To make it simpler, special value called effective value is introduced. Idea, if I have some signal, any periodic signal, plus I have any periodic signal loaded with resistance R and producing some heat 1, and I take ideal DC source, I don't know, from library, and here will be power P2. If these powers are equal, I can say what this DC source is equal to my signal. In what dimension equal? In what sense equal? It gives me the same amount of energy. Yeah? So idea elements of effective value of signal can be calculated as 1 divided by period, integrating from 0 to period, square of my signal in time. It's an RMS or effective value. Here, you see, RMS, yellow line loaded with resistor will produce as much heat as what? A type battery. Yeah. 1.5 volt, it's a standard small battery. So as an energy source, yellow signal is equivalent to, it was somewhere here. I don't know. Here it is. To ideal battery. For ideal AC voltage, let's say AC divided by square root. It's for case of cosine omega or sine omega. For them, it's just simple square root from 2. So in electrotechnics, to make AC circuits closer to DC, because it's easier to solve DC circuit, this vector amplitude is taken not a real signal amplitude, but its effective value of O RMS. Root main square. Now I can write what I can write. I can return to my, I have source, I have capacitor, I have resistance, and here will be ground, and this is Y, and here if I put a voltmeter here, it will be put input voltage, output voltage. One capacitor, one resistance. If you want, capacitor is 1/10 of microfarad and resistance is 500 ohms. Can I write output as a function of input? Who stops me? My blackboard, my rules. So for this circuit, I can write V x multiplied by resistance and divided by resistance plus 1 against omega c. Here is Steinmetz's idea. Substitute. Remember this nice integral. If I assume that input voltage is a vector on a complex plane, integration operation on it means just rotate backward and change amplitude S1 against capacitance. So for capacitors and reactive resistance being 1 against omega c. But this is usable only for harmonic signal, for ideal voltages. Be careful, it's only for sine or cosine omega t, not for anyone. It can be extended. The same trick can be done with the coils. I will show it. So here is Steinmetz's idea. You know the Ohm's law. Current proportional to voltage, yeah? Have you heard about Ohm's law? Or it's substituted by something different. So Ohm's law, current here will be voltage divided by resistance. To, let's say, stretch a classical Ohm's law to the AC circuit, Steinmetz offered idea. Let active resistance be active resistance. But for capacitors, instead of 1 divided by C integrals from 0 to time IC not T dt, let's use the imaginary resistance. Because integration of vector is just turn it back by 90 degrees and change scale. Why I'm writing this? Because I like to write formulas. No, I would like to introduce an idea here. An idea. What I put in the white cloud. It's some kind of function, yeah? Function of what? Frequency. Frequency. It's a function of frequency. I can write input multiplied by this H being white cloud is called a transfer function. I write this down to show you an idea of transfer function. Transfer function connects input and output. And the important thing about transfer function, it's a function of frequency. It can be applied to anything. What it's in space of frequency, we will use it. And it is not a transfer function. Do you see depends from input? No. It's simple function of frequency. So, this blue line is a yellow line multiplied by transfer function of this network. It's very simple network. One capacitor, one resistance. Who need network if you don't do something with network? What I'm doing with my network? I decrease frequency. Skip. And look what happened with the output. Frequency increases, output increases. Frequency decreases and output goes down. Is it correct? Low frequency, low output. High frequency, high output. Yeah? I can draw a nice chart. Here will be frequency, here will be output against input, or modulus of transfer function. What will be output at zero frequency? What your Facebook tells. What will be output at zero? I'm looking at you. What will be output at zero frequency? Zero. And if frequency is infinite, yeah? Infinite? Source is infinite. Yellow line is infinite line. Or it's just 1.5 volts. It will be it never be infinite. It will be equal to input. And this value, this here we have 0, here we will have 1. 1. It's a ratio. It will never exceed 1. Nice. What can we tell about this frequency? If about the circuit, it is, we speak about low frequencies. Boom, 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 boom. Someone's playing drums. Will it suppress low frequencies? Yeah. Low frequencies are here, they are suppressed. And someone high frequencies are passed without. This thing is called HPF, high pass filter. Circuit will suppress low frequency and passes through high frequency. You can ask your favorite Google, or I don't know, now everyone ask ChatGPT about this chart, and you will see what this slope is 6 decibels per octave. Wow! What what is decibel, what is octave, what is sol. This chart, often, all this chart, in any signals book on this earth, in any books, starting from books from brain damage dummies and ending with super high-end acoustic professional, they all draw it the same, 6 decibel per octave. Problem, in signal theory we need to deal with a huge range of signal. To make charts nicely, they often are drawn in logarithmic scale. For frequency, 1 octave means what per 1 unit, say it's F1 and it's F2, F2 will be double F1. For 1 unit of X scale, frequency doubles. Octave means what, I don't know, centimeter, meter, inch, name it. For 1 unit of horizontal scale, frequency doubles. Yeah? For vertical, it's more complex. Bell is a decimal logarithm of radius, but bell is a huge value. So often decibels are used. For voltage, current, anything, name it, but except power, ratio will be 20 decimal logarithm of, let's say, y2 divided by y1. 6 decibel is approximately 2 times. 10 decibels, 10 times 20, 130,000 and so on. It's a logarithmic scale. For power, it will be 10 decimal logarithm, let's say P2 against P1. Power, use 10. You will, if you dig deeper into theory of signal, you can see power rated in decibels as dB and voltages rated in decibel as dB single V. For power, basic, if you don't see 2 values but only 1, but named in decibel, possible it's rated, decibel is a relative value. So it's, let's say, taken against base level of 1 milliwatt. For voltages, as a basic level, as a 0 decibel, often is taken voltage produced 1 milliwatt on the load of 600 ohm, which is typical for old communication phone line. So it's approximately 0.707 volts. Here, nice diagram, telling us something about the circuit. It has a name, Bode plot. Name for it. It has a amplitude frequency characteristic. In Latvian, it will be AFR, amplitude frequency raksturīgi. In English, amplitude frequency plot or amplitude frequency chart. Here. At this point it's easy. Not too complicated, yeah? Now, tiny trick. Look. Harmonic in input, harmonic in output, yeah? Rectangles at input and some pi. Actually, it's an exponential, it's a decaying exponent. Harmonic input, harmonic output. Non-harmonic input and something different at output. I can also apply triangles. Input triangles, output some kind of rectangles. Huh, something wrong here. Not right, yeah? Something going on. Okay, let's put a mark on it. Now, I would like to test another circuit. Mirror of this one. What's a mirror? What will be mirror circuit? Resistance, capacitance, input, output. This circuit. Circuit. Okay. Day of funny circuits. Coil. You goes in. You goes here. I will put you here and something. Oh, yeah. Can we write a transfer function for this circuit? Will be something like 1 divided omega c divided by f, 1 divided by your omega c. This is 1. This is square root from -1. What can we expect from this circuit? How will it react on frequency? If frequency increases, what will happen with output? Frequency increases. Output voltage as a complex is input voltage multiplied by transfer function. Frequency increases. What will happen with output? Frequency goes up. If omega goes up, this term goes down, yeah? And this term too.
Yes.
And output goes down. Let's check. I increase frequency and output change scale. Low frequency, high output. High frequency, low output. So for this circuit, again, 6 decibel per octave. frequency, absolute value of amplitude of my transfer function, 1 or 0. 1 in radio means 0. Can you name it? Suppresses high frequencies and passes low frequencies. We have NPF passes drums and suppress. But what will happen? Harmonic input, harmonic output, note it. Square input, non-square output. Triangular input, no, something like sine. Again, non-harmonic signals are distorted. Harmonic signals pass without any distortion. What is the opposition, let's say, anticapacitor? We saw two circuits with capacitor, yeah? What is anticapacitor? What kind of energy stores capacitor? Do you believe what capacitors store energy? What your physics tell? Coil. Yeah, coil. Bring a coil here. Coil. One hundredth of Henry. Standard self-inductor coil. If capacitor store energy in what form? Electrostatic field. Coil can store energy in its magnetic field. Can I substitute capacitance with coil? Let's see. Something will happen. I'm sure. Oh. Let's say this one. Okay, you goes here. This one goes here. And something like this. Oh, circuit with the coil. Now I have circuit like this. Resistance, inductance, input voltage, output voltage. Who can tell me what's the coil voltage as a function of coil current? Coil. Do I have a coil? Coil. Oh, for example, this coil. Coil. What will be coil voltage as a function of coil current? Yeah, first derivative. It will be inductance, measure of coil, let's say magnetic capacity. Inductance. time. It's first derivative. It should be in physics course. Familiar object. Coil inside the coil and magnetic core. In my time, every school had this demo. Electromagnetic inductance. If you change current in the primary coil, you see the voltage in the secondary. If you have one coil, okay, it will be self EMF. Idea of Steinmetz. I can write again the second kilo voltage law with this inside and then integrate. But I can do an easy trick. I can substitute coil with imaginary XL being omega A. Because derivative of the complex vector will be scaled and rotated forward by 90 degrees vector. Will be, you just need to rotate this vector forward. For this circuit, transfer function, so output voltage will be input voltage multiplied by F divided by F plus omega A. Transfer function for this circuit. So, what will be reaction to the frequency change of this circuit? Can we tell something? Low frequency, this term is low, yeah?
So they identical
To
the input
to
the output.
at a low frequency, this will be
At low frequency, the output will be the same as the input. Oh, no.
no.
Okay, sorry.
At a low frequency, this will be low, and output will go down. If frequency is what will happen? Wait 1 second. This is what I have here. This is correct function. This is correct because I need to multiply not by this resistance but by this. Now it's better. At a low frequency it goes 0. Yes, this is correct. There you go. We need to check. Maybe low frequency, high frequency. Low, high. Looks possible. And what about squares? Here is circuit reaction to square input. Harmonic, square, triangles. Again, distortion. Actually, this circuit is another HPA, high pass filter. But what I'm seeing, harmonic input, harmonic output. Non-harmonic input, quite a strange output. One more circuit. It's a square or carré of circuits. Transfer function will be, this one is correct, R divided R plus your omega A. APF. Should I assemble it? Every circuit should have right to be assembled. I'm doing something. I just try to make a short circuit. Here it is. Here is our circuit. Low frequency, they are equal. Higher frequencies, output goes down. What's expected? And again distortion. Triangles, like sine, squares. Something close to wave ideal. We saw 4 circuits. All the circuits, they have one common thing. Differential equation describing them has one root. All these 4 circuits are so-called first degree or first order circuits. First order circuits. Just to make everything more complicated, I can bring in the second order. Here I have a second order circuit. One of that. Small capacitor. Coil. Variable capacitor. This goes to ground. To take off output, this will be, and here I will have an input. Possible I will have an input. So black to black, white to white, and you come here. input something, output nothing. Oh, here it is. Scale. Oh. 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 Nice characteristic. Key element, this capacitance, this inductance. A, B. You can write a simple equation. Imaginary part of AB conductance equals to 0. It will yield you a one particular frequency of resonance. This frequency 0 will be 1 divided by square root of LC. Simple, when dot omega plus 1 divided omega equals to 0. If you solve this equation, you will get one particular frequency. In my case, it's 238 kilohertz. This circuit will have a transfer function. We will speak on them later. Something like this, around some central frequency. Harmonic input, harmonic output. I shift frequency, output disappears. Forward, again disappears. Can I adjust it? And now I will switch to rectangles. Wow. Interesting, isn't it? Again distortion. I put rectangles on input and I have harmonic signal on output. I think I can lower frequency. Oh. Hmm. One. Opposite direction. This one. And the left. See what a strange thing? Input rectangle, output harmonic, but what about frequencies? They are different. Something wrong here. I can find, oh, here. Input rectangle, output. If I switch to sine, there will be zero output. Some kind of black magic. Who invented this electrotechnics? I need one more. Should be somewhere. Oh, here it is. Input rectangles, output sine with the same frequency. Input sine, output sine. This is fine. But if I go to another frequency, going. Where are you? Oh, here it is. Input rectangle, output harmonic, and frequency are different. Take a look. Definitely, I think it's 5 times. One or three. 1, 2, 3. 3 times. Yeah, 3. 3 times. Strange, isn't it? Something wrong here. Looks like a bad magic. And it's only on one particular frequency. Explanation. We need explanation. Now I have a question. Why both low pass and high pass filters disturb rectangular signal, any non-harmonic signal? One. And second, what's going on? Why second order or band pass filter makes sine from rectangles? This is unclear. I knew how to clarify it. What shall I do? What shall I do? What shall I do? 5 minutes. Maybe we can take a break now, and next hour I should clarify this. All this. At this moment I have questions, but no one says answers. Answers are there. Answers are waiting. Okay. In half an hour, yeah? But in third, we will go for answers. Maybe some questions? Huh? But if you have questions, raise your hand. Don't worry, no one kills you.